In order to do regression on your calculator, you need to first turn on the diagnostic, which might already be on, but it might not be. So to do that, press second catalog, and then you need to scroll down to the D's. So you can just press this key because there's a green D here, and it will jump down to the D's, and then you need to scroll down further all the way to diagnostic on and press enter, and then press enter one more time. The next thing you need to do is enter the data that you're working with, and so to do that you press stat and edit, and then enter the data that's in the table here. I already did a couple of them, but I need to put in 300 and 900 and 10.4 and 12.2. Alright, so we have the data in there. You could set up your window so that you could see that data. The x's are from about 0 to 1,000 and scale by hundreds. And the y's are going from about 0 to 20, we'll say. Then you can do second stat plot to turn the plots on. And we have our X list in L1 and our Y list in L2. And so just press enter to make sure that the box around the on is highlighted. And then if you press graph, you should see the data plotted. I'm going to delete these functions out of here. Should have done that already. And so there's the points. And if we want to try and find a function that fits that data, we do stat calculate. And your choices are that it might be linear, exponential, power, or logarithmic. So if you don't have any idea what it should be, press linear. And then you can see that the default is that it thinks your X list is in L1 and your Y list is in L2. And you can skip the frequency list and the store. So press enter, enter, enter to store it. If you press alpha F4, you can get Y1, which means it'll take the equation that it calculates and store it into Y1 for you. And then press enter and ask it to calculate it. So this R value of 0.87 means that the data is not a very good fit. The closer this number is to 1, it means that your function fits the data better when this number is closer to 1. So when you graph that, you can see that a line is not a great fit for this data. That's the line of best fit, but that's not a very good fit. So then to try a different function, do stat calculate, and let's try a power function. So we do power regression, keep all this, store alpha F4, put it into Y1, and calculate. So 0.98, that's a pretty good R value. Let's graph it, see what it looks like. Pretty good. And then let's try a stat calculate. Let's try a log regression. This ln is standing for natural log. That's fine. It doesn't matter what type of what base you use. So same thing. Store vars y vars. This is another way that you can get to the y1 function y1 and then calculate. And then that R value of 0.999 indicates that that's probably the best fit. You could graph it and see. And so that looks great. To be complete, you could also try an exponential regression. We haven't tried that one yet. Scroll down here to find EXP and L1, L2, store the regression equation. Again, instead of using the alpha F4, you can use vars, y vars, function, y1. If you don't have the newer operating system, that's a way that you can get y1. And then calculate. And then it does not fit an exponential function very well. You can see that curve does not fit that data very well. So the log one was the best, and then from there you'd state the type of function that fits the data best and give the R value. So we need that function back. Okay, so I redid that logarithmic regression, and this is the function of best fit. And we can tell that it fits the data nicely. So now I filled in the answer to question A, that's the log function where R is approximately 1. B, the function of best fit with the values rounded to 2 decimal places is y equals 1.30 plus 1.6 times the natural log of x. That's coming from this information here. A is 1.3, so the A value fills in right here, and the B value of 1.6 goes right here, and then the function times natural log of x. So then it says, describe what type of, or graph this function on your calculator. We did that. Describe which type of graph paper would be used to make the data appear linear. So I already put this graph paper here, but I know that this one's right because the x values range from 2 to 900. That's a big jump, but the y values don't jump up very much at all. So having this be a linear scale vertically and a logarithmic scale horizontally is what will make this work. So in trying to decide how to scale your data, remember these have to be powers of 10, and 2 has to fit on there. So 1, and then times 1 by 10 to get 10, and times 10 by 10 to get 100, and then times 10 again will give you 1000. So this data will fit nicely on there, and then the y's need to range from 2 up to 12. So I think if we put this as 0, 5, 10, right there, and 15, we'll be able to fit the points. So just doing one of them, remember this is already 1 over, so 2 over would be here, and up 1, 2.4. Be about right there. And over 10 is obvious, up 5, and over 300 there's 100, and then this is what you're counting by, 200, 300, and up 10.4, that's 11, so 10.4 will be about right there, and then over 900 will be the line just shy of 1,000, and up 12.2, that's 10, 11, 12. And if you've done this right, you should be able to use a ruler and connect all of your points to form a straight line. Mine are just a little bit off. I don't know what happened here. Let's see. Over 100, 200, 300, and up 10.4. So that's pretty good. Remember that we are finding a function of best fit, so the points might not fit the data exactly on this one, because the points were given to us and we're trying to find the line of best fit. So the line might not go through them exactly, but it should be a reasonable representation of the data, since we know that this function fit the curve pretty well. It's the same idea as in this graph, that this logarithmic function of best fit may not go right through the middle of these points. This is a pretty good representation, but if it was a little bit off, it would still be a good fit.